All right, before we get started, I first want to thank Todd and AILA for organizing this event and inviting me here tonight. Like Todd said, this is the first time I've presented this topic before, so I'm excited about it, and I hope it doesn't completely flop. But I also want to thank Supply Frame for hosting tonight. I love this space, and so it's an honor to get to use this space for this event. Innovate Pasadena, of course, for sponsoring, and they do such important work for the tech community and for the design community here in Pasadena. I also want to mention NILO, which is kind of a media sponsor for this event. So if you're not familiar with NILO, it's the Northeast LA UX group, and one of our board members is here. You should check them out if you're interested in user experience design. NILO sort of covers the area from downtown LA to Pasadena, San Gabriel Valley, and all the way out to Burbank. We do lots of great events, and we have a lot of exciting events planned for this year. And also, my company was a co-sponsor for this as well, Interactivism, which is a digital product design agency. We do a lot of enterprise level design. We're doing a lot of UX design for AIs and machine learning systems. And so a lot of this research applies to projects that we're currently doing right now, which is very exciting. I do want to say that I am a UX designer. I'm not a psychologist or a neuroscientist. There's a lot of neuroscience and computer science in this talk. And as a UX designer, I'm finding increasingly that I need to sort of teach myself to become an expert in these other fields. And I think that UX design is much more science than it is art. And it's combining a lot of scientific fields from neuroscience to psychology to computer science. And even physics and some of the social sciences. And so it's a very multidisciplinary field, and I am constantly reading and trying to educate myself about these other subject matter. I also want to acknowledge the work of Dr. Todd Kashdan, Dr. Patrick McKnight, and Dr. Melissa Stixma, and their colleagues at George Mason University. And I also want to acknowledge the work of Pulkit Agrawal and his colleagues at the Computer Science Department at UC Berkeley. Much of the content of this talk and the research that went into this talk is based on their work. And they and lots and lots of other people are doing really incredible work in this field. So tonight's talk is about designing curiosity. And how this applies both to thinking machines and also to people. So to start off with, what is curiosity? So curiosity occupies this very critical position in the study of things like emotion and motivation and cognition. And it has a lot of implications on fields as wide-ranging as biology and robotics, design, economics, and artificial intelligence. But there's been a lot of debate about how to define what curiosity is. So there is some general agreement that the immediate function of curiosity is to actively pursue, explore, and immerse oneself in situations in order to gain new information and experiences. So acting on feelings of curiosity satisfies a human drive or need to expand knowledge, to build new skill sets, to inspire creativity, and in some cases to bolster social relationships. So some common behaviors of curious people are that they ask a lot of unprompted questions. And we notice this a lot in children as well. So children are naturally curious. They ask lots and lots of questions. Curious people tend to read to acquire knowledge. They examine interesting images and manipulate interesting objects. They investigate how people think, feel, and behave. They take risks to acquire new experiences. And they also persist at new tasks that are challenging, and they often seek out tasks because they are challenging. And so this, these are some behaviors that we observe in people that psychologists and neuroscientists identify as being curious. So originally there was a two-dimensional scale, and this scale, based on these common understandings of curious behavior, was developed by Dr. Cashton at George Mason University. And the first facet of this two-dimensional scale is what they called exploration. So exploration can be described as recognizing and seeking out new information and experiences. So it's this action of going out and exploring. It can be a physical exploration like this, or it can be a more cognitive or mental one. And then the other aspect of this two-dimensional scale is what they call absorption. So absorption is to be focused and engaged in an activity such that time seems to move slower. And this is something that's a very interesting aspect that they observe in a lot of people who are absorbed in an activity where they're very focused and engaged. And we won't get into the time aspect, but it's an interesting sort of phenomenon that's commonly observed when people are absorbed in a curious activity. But this two-dimensional scale has some problems, and so Dr. Cashton and his colleagues sort of went back and re-examined this. And one of the problems is that sometimes we explore for reasons other than curiosity. So for instance, to find something or to complete a task. And so for example, the Coast Guard doesn't explore for curiosity's sake. They explore because they have a job to do, and that job might be focused on public safety or national security or other things. And so there's task-based exploring that's not curiosity-based. And the same is true with absorption. And so there's task-based absorption. Sometimes we're absorbed in activity for reasons other than curiosity, such as physical exercise, or stress-based absorption, or doing some work. And so, for example, when you're absorbed in your work to meet a deadline, you're driven not by curiosity, but perhaps by fear, or by needing to earn a living, etc. So psychologists re-examined this. They came up with a new two-dimensional scale. And they essentially relabeled those two facets. And so the first facet was relabeled as stretching. And stretching can be defined as the motivation to seek out new information and experiences. And so it's more sort of motivationally oriented rather than behaviorally oriented. And then the second facet was relabeled embracing. And embracing is a willingness to embrace the uncertain and unpredictable nature of everyday life. And we see this in the way in which children learn. And so the nice thing about this modified scale is that it's based on the intentionality and therefore the cognition of curiosity first and actions second. And thus, the actions can be evaluated specifically as expressions of curiosity and not as other types of motivations. And scientists consider these to be essential, but they still don't express either the full nature of curiosity or the types of curious people in a very comprehensive manner. And so what Dr. Cashton did, along with a large group of his colleagues, is they went back to the drawing board again, and they did about 6 years of research, and they analyzed data from nearly 2,000 adults. And they wanted to identify more specifically what the full spectrum of curiosity is, and also to define what a curious person is. So they were looking to expand that scale on both sides. And they discovered that it was far more multidimensional than they first assumed that it would be. So they discovered that there were actually 5 different types of curiosity when they broke down this behavior. So the first is what they call joyous exploration. And the second is called deprivation sensitivity. And the third is called stress tolerance. The fourth is called social curiosity. And the fifth is called thrill seeking. And what we'll do is we'll go through each of these and sort of break down what they mean. So joyous exploration, the recognition and desire to seek out new knowledge and information, and the subsequent joy of learning. So this is, you could call this curiosity for curiosity's sake. And we see this exhibited in the way in which most children learn. It's why they incessantly ask why. But we also see it in some adults, this sort of joy of exploration, of learning. The second facet is called deprivation sensitivity. And this is an emotional curiosity that's driven more by tension and hard labor than joy. So it's things like pondering complex ideas, solving difficult problems, and striving to diminish gaps in knowledge. So learning new things and acquiring new skills satisfies a curiosity to continuously master new things. And people like this often feel a sensitivity to being deprived of challenges. That's why they call it deprivation sensitivity. It's why people do puzzles. People take non-degree adult learning classes. They take joy in learning new skills or languages, not in spite of it being hard, but because it is hard. That there's something about the difficulty of the task that is satisfying this type of curiosity. The next facet is called stress tolerance. And so this is the willingness to embrace the stress and ambiguity of exploring new, mysterious, or risky experiences. And this is the primary driver of people who love to travel and experience new cultures, or go wilderness trekking, or try new foods, where even the discomfort and stress that comes with it is not a negative. It's actually a positive aspect of it. And things like travel, we talk about, people love to travel, how wonderful travel is and what a wonderful experience it is. But it's also stressful and it's uncomfortable. And flying on airplanes is not a joyful experience. But it does satisfy this stress tolerance curiosity. The next is social curiosity. And this is the desire to know what other people are thinking and doing by listening, talking, and socializing with other people. So people like this love gossip. They love to listen to conversations and observe behavior. They love to eavesdrop on other people. They're not just nosy, they're actually sort of natural anthropologists. So social media and celebrity gossip, for example, feed that social curiosity. And actually it can become quite addictive in these forms. So social media platforms are sort of exploiting our social curiosity. And then the fifth and final facet is called thrill seeking. And this is the willingness to take physical, social, and financial risks in order to acquire intense experiences. So this is all about experience acquisition. So you can think of extreme sports like skydiving, but it's not exclusive to this. This also applies to serial entrepreneurs, that thrill of that risk of starting a new company. It also applies to stand-up comedians, that thrill of the risk of social embarrassment. And that sort of thrill of starting a new company that might fail, in fact it has a high probability of failing, or jumping out of an airplane, or doing a stand-up comedy routine where you might fall on your face. This is satisfying that thrill-seeking curiosity. So those are the 5 facets of curiosity. But they also found in their research that there are different types of curious people. And those types of curious people are the fascinated, the problem solvers, the empathizers, and the avoiders. And I think the best way to look at this is actually in a sort of visual matrix where we can cross-reference this. And so what's interesting about this is that it turns out there aren't just curious or incurious people, that there are different types of curious people. So it's more complex than they originally thought. So this is the matrix that I created to sort of visualize this. And so we can see how each type of curious person compares to one another. So starting with the fascinated person. The fascinated person scores high across all types of curiosity, especially joyous exploration. The problem solvers score high in deprivation sensitivity and medium across the rest of the spectrum. And so these are the people who love to solve problems, they love to do puzzles and learn new things. The empathizers score high in social curiosity and medium across the rest of the spectrum. So these are our anthropologists and our Facebook addicts. And then we have the avoiders who score low across the whole spectrum, especially stress tolerance, which is pretty interesting. So these are the people who really hate to travel. We were supposed to have some avoiders here tonight, but they canceled. I don't know why they always cancel them. But this becomes a very interesting spectrum because you can see that curious people are curious in lots of different ways. They just might be more curious in some ways than others. So even if we're a problem solver, we might still find something interesting by looking at celebrity gossip or listening into a conversation or observing people at a cafe. And this becomes very useful as a design tool, and it also has some really interesting applications when we start to think about machine learning and artificial intelligence. So there are a lot of different ways that AI can be applied. And curiosity should be an integral part of artificial intelligence design, both in how and what types of information AIs seek out, but also in how AIs learn and solve problems, and also in how AIs engage with or augment our natural curiosity. And it's one of the areas that I think there's going to be a huge need in terms of the user experience design of AIs, is what is that AI-human interface going to look like, and what is that interaction going to look like? So some people are actually working on this, on how to create curiosity in an algorithm, essentially. So a computer algorithm designed with artificial curiosity can learn to solve different problems even when there isn't an immediate sort of clear course of action that needs to be taken to solve that problem. And this is an area where sometimes AIs can get bogged down. Like AIs are great at crunching numbers and large amounts of information, but sometimes it's not clear what path needs to be taken. And a trial and error approach can be inefficient. So researchers at UC Berkeley developed what they called an intrinsic curiosity model, so that even when there isn't a strong feedback symbol, the learning algorithm can still work. And we'll look now at how they did that. So a lot of AIs use what's called reinforcement learning, which involves using positive rewards to guide an algorithm's behavior towards a particular goal. And it's a method that's made it possible for machines to learn things that are very difficult to define in code. So it was used, for example, to teach the Google AI called DeepMind to play the complex board game Go with really amazing skill. It was able to beat some of the best Go players in the world just by this sort of reinforcement learning model. However, reinforcement learning is often inefficient, and it relies on accurate and immediate feedback. And sometimes when there are problems where there isn't immediate feedback, or the feedback may not be accurate, or the AI may not know which feedbacks are relevant. So the researchers at Berkeley tried combining reinforcement learning with artificial curiosity. And they tried it with two simple video games. And one of them is called VizDoom, which is a 3D game like this. And the other is Mario Brothers, which is a more two-dimensional game. And so the use of artificial curiosity made the learning process far more efficient in both games than simply positive reinforcement. And so, for example, in VizDoom, instead of redundantly bumping into walls, the AI-controlled character moved more cautiously around its environment, and this enabled it to learn to navigate and master the game a lot more quickly because it wasn't just looking for positive feedback. The algorithm had some natural curiosity about how the game worked and how to master it and how to explore its environment. So even without any other award, the agent was able to navigate both games surprisingly well, and it made far fewer errors in figuring out how to play. So in Mario Brothers, it learned to avoid getting killed because this lessened its ability to explore and learn about its environment. So the AI's need to fulfill its own curiosity became a motivating factor to stay alive. And the same could probably be said about a lot of humans as well. So if we look at that on the curiosity matrix here, we can see that essentially their intrinsic curiosity model meant that the AI is a one-dimensional problem solver. It's essentially employing a deprivation sensitivity mode of curiosity. But as you can see, this is a very one-dimensional type of curious machine with only one mode of curiosity. And so this really doesn't match what a problem-solving human would look like, because a problem-solving human would also have medium curiosity scores in other facets of the curiosity spectrum. So as promising as this is, an AI with only one dimension of curiosity has a very egocentric view of the world. Most people are more broadly curious. So regardless of which type of curious person they are, people tend to want to learn about the world in ways which are not necessarily directly tied to themselves. So why else would we read about celebrity gossip or watch documentaries, for example? What a celebrity is doing or what's happening in a documentary doesn't affect me directly, but I'm still curious about those things. Whereas the AI was primarily concerned with only what was happening to itself. And that's why that one-dimensional curiosity model for the intrinsic curiosity algorithm is very limited. So AIs will become more potent problem solvers, I believe, if their intrinsic curiosity models are designed to more closely resemble the full spectrum of the curiosity matrix. So for instance, natural language processing algorithms could employ joyous exploration to expand their vocabulary and improve their grammatical style, just as human writers and orators find joy in discovering new synonyms and metaphors. AIs will be more relatable if they can engage with our own complex modes of curiosity, knowing when to engage with our social curiosity, when to challenge our deprivation sensitivity, how to understand our stress tolerance curiosity, and also how to help us with our thrill-seeking. As more aspects of our lives become AI-driven, we need the right types of curiosity in order to solve problems and to engage with us in ways that engender trust. And trust is one of the major sort of issues that we're dealing with a lot of automated and artificially intelligent systems. So, for example, a self-driving car with no human controls could be curious to find a more efficient route. And we need to be able to trust these vehicles if they don't have a steering wheel, for example. And there are a lot of prototypes of self-driving vehicles coming out now that don't have any controls in them. They're 100% self-driving. So if the vehicle is curious to find a more efficient route, or maybe a more interesting route or a more scenic route, it should be able to do that, but also engage us in a way that engenders trust. If a self-driving car had a thrill-seeking mode of curiosity, that could be a little terrifying. An AI doctor could use deprivation sensitivity and joyous exploration modes of curiosity to help it diagnose medical problems. And we are seeing now AIs which are extremely efficient at doing things like predicting cancer or analyzing CAT scans and MRIs and things like that. So they can be very good at diagnosis and maybe better than humans. But social curiosity would be required to develop good bedside manner and cultivate trust. And this is a very important aspect of the medical experience. So how can we design for this? Well, one way is to incorporate the curiosity matrix in the traditional UX persona. And so in typical UX work, the curiosity matrix can enhance our understanding of how to engage with users' natural tendencies. And as a design tool for AI, personas can be used as blueprints for designing intrinsic curiosity models to user experiences with AIs. And these really go hand in hand. They can help AIs become more effective and more trustworthy at the same time. And I believe that the curiosity matrix can be a key component in achieving both of these things, both trust and also effectiveness. And so this is something that is not currently standard in UX personas, but it's something that we are actually going to start doing at our company and start testing and validating this. And I encourage you to take this curiosity matrix and try it out for yourselves as well. There may be different ways of scoring it, and certainly we want to also validate this with the scientific research that's out there. So, thank you very much. I'm happy to take questions.